So we'll get started with today's webinar. We've got open cell foam, spray foam, where we're going to discuss the comfort, compliance, and code clarity. We have our good friend here, Cody Wilson. I've known him for quite some time when he was with Owens Corning. Answered a lot of technical questions for me when it comes to installation, which we've talked multiple times on this on our YouTube channel. And then he'll go through some open cell foam stuff here. Before we begin, as always, we got some quick housekeeping stuff. So the webinar is being recorded. It will be uploaded to our YouTube channel probably about 72 hours after the recording. You can go to our YouTube channel or our website and actually click on news and resources page. You can find our YouTube channel there. So if you got anybody that you want to show this to after our live session, you can always rewatch that on our YouTube channel. So today's session is eligible, as always, for ICC CEUs. In order to receive those credits, you'll have to be on the call for at least 75% or 3/4 of the presentation. Within about 72 hours, you'll receive an email from Kathy Lawrence. She'll send you a brief course evaluation. Please complete that and return the survey to receive your certificate. Let's see. I will have the chat feature open. Feel free to use that. If you experience any technical difficulties or if you want to ask a question there, I see a lot of hello, we're here and present. Thank you guys for being here. Also, we'll have the Q&A feature available as well. So we're also encouraging you guys to submit questions as we go throughout the session. We'll try to go ahead and answer those as they come up as well. And if anybody is new to Spear and who Spear is and what we do, welcome and thanks for joining us. This is what we do usually once or twice a month. So we are one of 6 energy efficiency organizations, or a RIO. We're here to help. We offer free training, including webinars, in-person sessions, and even field support. I can also help do IECC test prep as well if you've got anybody looking to take the test. If you have any questions about energy code or ASHRAE 90.1, if you're a plan reviewer, a building official, a third-party inspector, or a homeowner, always happy to help. We also work with quite a few cities to help them with the adoption of the 2021 and now the 2024 that's out there. We can help understand those amendments and help guide you guys through what other cities are doing to help minimize the impact for some of your building community. So me and Cody will share our contact information at the end of the presentation. Always feel free to reach out, and let's get started. So first and foremost, Cody, if you want, we can kind of just click off our cameras here and just get rolling with what we've got. But first and foremost, I just wanted to answer the question of what is spray foam. I mean, spray foam is just another type of building insulation. It comes in liquid form. It's sprayed on walls, ceilings, other surfaces. It expands and hardens into a solid or a kind of a fluffy, air-pocketed insulation. So its primary purpose is basically to insulate buildings. It helps retain heat, and inside it also helps slow resistance of heat transfer into the building. In the end result, it is increasing our energy efficiency and comfort inside the building. So there's basically 2 main types. We'll talk more about that. Cody definitely has a lot more technical information than I do. But my high level is basically we've got open cell, we've got closed cell, and there are distinct properties of those 2. So the brief history of spray foam, I mean, I've got this up here on the slide, but Cody, if you've got some more information, jump right in. But it's been around since the 1940s, I'm assuming. That's what we see on Google, and that's what we find. I'm assuming it wasn't specifically for residential back then. Do you have an idea of what it was in the very beginning and what it was used for?
It kind of was like the same thing when they started with radiant barrier. It was to try to, stop thermal envelopes. I mean, as far as, stopping heat transfer. And so that's kind of, I mean, if you think about foams in the past, I mean, look at your coolers and ice chests. I mean, the different cooler, like even those disposable ones that you used to get at 7-Eleven back in the day. And then, so it's been around a while. It just didn't start getting popular in the home construction industry. I mean, I didn't start seeing it become popular until like the late 90s, early 2000s is when it really started to take off, along with other products.
Yeah, I mean, I see here, that's been used in airplanes, but also it looks like the popularity started growing because they were trying to get rid of asbestos materials. It was a big insulator back in the probably in the late 40s, 50s, 60s, and 70s. So appreciate that. Types of open or types of spray foam we've got here. I've just listed the two. I don't know if there's any technology that's moved on and added anything else, but we've got basic open cell and closed cell. Open cell is real easy to determine whether you've got it. It's soft, it's flexible. You can really kind of push it like a sponge. It's basically you got air bubbles in it and it allows air to fill in those spaces, which gives us our R value and our thermal resistance for heat transfer. And then it's kind of that spongy texture. And then closed cell is more rigid. It's dense. Each of those bubbles have cell walls remaining intact. They don't actually rupture like it does in open cell. But it does make it more stable and produces a much higher R value per inch and a higher strength as well. So properties, just real quick here, and I'll just mention this. If you want to jump in, Cody, that's great. If there's, I know this is probably just generic, but most of the time, open cell is anywhere from 3.6 to 3.8 per inch of R value. Closed cell is basically a 6 to 7, and I'm assuming that is determined by mode of spraying and or the wetting agent or blowing agent that's in it or company. Is that correct, Cody?
Yeah, and the 3.6 to 3.8 varies. I mean, I have seen foams less than 3.6. So, but you can take a look on their ESR reports and it will tell you, what their R value per inch is. But on average, that is the numbers that you have there are correct.
Okay. And then one thing I keep getting questions about, there's different answers that I find on Google is when does open cell become an air barrier? I know open cell can act as a good air barrier, but not a vapor barrier. But at a certain point, that's when the manufacturer says it's an air barrier. Is that roughly, I've heard 2 inch, I've heard 4 inch. What's your take on that?
Well, it really bases on the ESR report will tell you the minimum inches, but on average, it's anywhere to 2 to 3 inches where it starts to work as an air barrier.
Okay, that's kind of what I assumed. And
For
that's
for
again
for,
why we're
for
doing
op
2x4.
Yeah,
Yeah,
and
go
that's
ahead.
for open cell. For closed cell, you can get an air barrier, from 1 to 2 inches.
Got it. Do you see any closed cell at all really happening in Texas other than commercial applications?
Yeah, actually, closed cell becomes more popular when we start talking about barn doors and metal buildings because you don't want to spray open cell on a metal building because the open cell, like you said, it's got open cells in it, so it can absorb the moisture. So we don't spray open cell on metal buildings. So normally, what we would do to maximize the R value in that case is we would do 1 inch of closed cell because it's so much more expensive to create that barrier and then you can spray open cell on top of the closed cell to maximize the R value without having to put any issues with the absorption of the metal touching the open cell foam.
Oh, that's great. Okay, that I didn't really know all of that. I know there's someone on the call today that actually is going to build a barn dough, so that's good information. Thank you for that one. So benefits of spray foam, of course, energy efficiency. It provides thermal resistance, basically reducing heat transfer, lowering our energy bills. It has air sealing capabilities. We just talked about that. Moisture control. Cody just mentioned kind of how they're doing that with different type of buildings and building structure and material being sprayed on. The longevity, of course, once applied, it doesn't settle or sag over time like some of the other insulation properties out or other insulation materials out there do. Cellulose is one of them that I know it's kind of dense and heavy on its own, so over time it can settle. And of course, it also does make a good sound reduction. You can dampen sound, contributing to quieter indoor environments. I know a lot of times this is big around airports because it helps quieten the interior of the home if you're spraying around even just a small 2x4 wall in and around an airport area.
And
So
it's
major
also
advantages, of course, we've talked about some already, but major advantages of spray foam, we've got improved comfort, we've got no temperature fluctuations. We'll talk more about this a little bit, but once you do a spray foam encapsulated house, you're going to include the attic. And usually in Texas, we can have a temperature differential between the ceiling that you're looking at from the interior to just a few inches after that, you're in the 130 to 140 degrees. So Spray foam can actually reduce and almost eliminate that temperature fluctuations you have between that. And then, of course, moisture deterrent, air quality improvement. You're sealing all those holes that usually allow for outdoor air pollution or other things to transfer into the building. Ease of installation. I'm sure Cody's team has perfected the way that they install it. It's quick, it's easy, it's simple. You're in and you're out. And of course, we talked about noise reduction, and then of course eco-friendly as well. So, anything to add to that, Cody?
Yeah, well, we were talking about other applications that are popular for closed cell. Another application that we normally see it on are crawl spaces.
Oh, that's a great point. Most of the time, I'm assuming they could either be as if it's an unvented, then it's on the walls of the crawl space. If it is vented, then you can do the floor below or
Yeah,
above the crawl space.
yeah, and there there's the moisture and the and benefit, the R value benefit, and then there's also because closed cell is a little more structural sound. So it actually provides a little more of a structural on that crawl space. You know, when you step on a floor that's a crawl, you can feel, the joist moving around and it helps with that stability as well. We've done when I was with Owens Corning, we've done several tests on, what different types of solutions in crawl spaces that could help with that. And unfortunately, I mean, foam is the probably doing foam underneath the crawl space was the most, I wouldn't say there's other ways of doing it, but as far as simplicity and being able to get the results that you want without spending tons more money, I always look at a bang for your buck type of analysis. And, spray foam works really well in a crawl space area. We've done other things in the past, especially with like historical buildings where they don't want to use foam. We've used rigid foam and things like that, but without getting into the weeds, the most cost-effective solution that we've seen that works the most is closed cell underneath in those crawl spaces, as long as
That's
you
a great.
prepare it correctly.
Yeah, that's a great point about rigidity. I mean, we talked about that on a previous slide, but I didn't actually equate that to making the floor more solid and stable. So that's a good point. Especially on older buildings, if they're not replacing the floor, those boards that are in there could already have some movement to it, so that could help solidify the structure. That's great. So benefits we already talked about here, but why would builders choose foam over fiberglass and other types of insulation? We've mentioned most of those already, but Cody, is there a like if you go out to talk to a new builder, I mean, what's when you start talking about foam, what's the biggest advantage that they end up going with using foam over fiberglass that have you found in talking to other builders?
Yeah, I mean, we kind of talked about this. I mean, just to give you a little brief background of for myself, when I was with Owens Corning for 10 years and I was a market development leader and I worked with their building science department. And the ironic part was when I first started working for Owens Corning, my job was to sell against spray foam because fiberglass was losing market share. So as you go through that process to try to find other efficient ways without using foam, because I mean there are some risk involved of using foam. You're trying to manufacture something on site, you got different temperatures, there's all these different variances. But what I did in the 9 years that we were talking about that was to follow the science. And there's places where foam works really well, and there's some places where foam doesn't make much sense. And so when I followed the science all those years, and a lot of the feedback that I would get is, oh, well, you're giving us this solution because you don't have a foam product. And then ironically, 8 years later, Owens Corning buys Natural Polymers, which is a foam company. So you can only imagine the amount of phone calls I got. And they're like, well, what are your thoughts? I said, my stance on where foam should go doesn't change if you follow the science. I said, all it does is validate because now I do have a foam product and I'm still telling you not to put it in certain areas. And so when you're talking about the solution and you're looking at where you're going to get the best bang for your buck, where is the air leakage coming into the house, and what you can do to minimize that and maximizing your R value. And then foam does a really good job of air sealing, but if you're going to use a blanket approach to air seal a building And the air leakage, let's say, a perfect example is for the walls. A lot of people like to spray foam the walls. Well, if you look at the science behind where air leakage is coming from, you're talking about 10 to 15% of the cavity of that wall cavity is where the leakage is coming from, where the majority of it is coming from your attic. So you can spray foam the wall, correct, but you're not going to maximize the R value in that wall cavity. So, for instance, in a 2x6 cavity, and we have this in the slide, but in a 2x6 wall cavity, you go spray that wall cavity. Well, I mean, the most you're going to get is about an R19, and if you shave it, you'll get about an R20 in that cavity. If I net and blow a fiberglass in that wall, I can get an R24 in that cavity at a right around the same cost it would cost me to foam it. And then, but it's a two-step process. You have to seal the wall first and basically poly seal around that wall cavity. But once you stop the air in a cavity, R value is R value. So you're not, so where do you maximize the R value? And if I'm only really sealing 15% of the leakage of the entire house coming from that wall, then I'm maximizing the air leakage not coming into the wall and then maximizing the R value. And now I've just got an R24 for the same price I just spent on spray foaming a wall. And so it's looking at those things or where you want to put the foam. If you want to maximize the R value in a wall, and we have this in slides that I can show you later on, then putting the foam on the outside of the house is where you're going to maximize it. So it's if you follow the science where you can maximize the R value, and then there's a big conception that open cell foam is great for sound. Well, I mean, really, when you talk about the wall assembly itself, that's where you maximize your STC rating. And a blown in fiberglass wall, for instance, can actually give you just as good as an STC rating and sometimes even better than you can get with foam in a wall. It's all depends on what type of RC channels, what type of drywall you're using. If you look at the entire assembly, so you're going to spend more money doing something to where you can maximize it. And that's kind of where you look at that, bang for your buck analysis to find out where's the right product, where you're going to go, and what you want to do to maximize that. And where do you want to spend that money on maximizing what product you want to put in that cavity. And
Right.
so, and that's kind of where you start looking at it. I mean, because I mean, to me, using both products and maximizing that is where you get best benefit. And we could talk about that later in some of the slides that we have.
Okay, and then just for clarification, I'm assuming STC is sound transfer
Correct.
rating. Okay.
Yeah. We're talking about sound transfer through a wall cavity. There's certain things that you can do to maximize that without spending tons of money of doing it. And it's all about just understanding, the laws of physics, understanding how sound's being transmitted through. And because I mean, you can foam the wall, but you still have the drywall touching the stud. So where does how does that stop the transmission of sound? So there's just different things when you're talking about the thermal envelope of the cavity. But where
Right.
foam makes the most sense is underneath the roof deck because it's the most simple way to put your ducts in the conditioned area so the air conditioning is not working that hard to cool off the system.
Right, which brings us right into our next topic, basically just talking about identifying the thermal envelope. So I've been an energy rater for well over a decade, seen a lot of things that I'm sure you've seen that just get you scratching your head going, what were they thinking here? But I've just seen recently, and as we've talked about, and you said a minute ago, you have to determine where are you going to put this, and is it the right place for application? We've seen people that do foam. They foam the walls, and then they foam the floor of the attic, which this picture kind of shows an envelope and a thermal envelope to follow. We don't know what type of insulation they're using, but in Texas, especially the humid side of Texas where this was at, there was 5.5 inches of foam on the floor of the attic, not on the ceiling joist and rafters above, which created the way I did it scientifically is it moved the dew point to the interior of the home, which now causes organic growth on the walls to happen. And of course, they equated it to we have a problem with the air conditioner, and it really wasn't. It was a location of the thermal envelope. So, as a rater and as an installer of foam like Cody and his team, the first and foremost, you walk into a house, he's already going to have the plans, he knows what he's looking at. but then the framer may have done something different. They have to identify the envelope and trace it. It's always funny to say, well, how do I determine this actually is there and how it works? And we'll see pictures on the next couple of slides. But it's always kind of we talk about it in theory of, look, if I have a pen and paper and I drew a house plan like what we see here, if I have a pencil or a pen, I should be able to trace that envelope without ever lifting that pen or that pencil. And if I do, there's a misalignment or a gap in the thermal envelope, which with foam can cause and wreak havoc on a house, kind of like what we're seeing here. You guys have probably seen this on previous webinars that I've done, but looking at homes that have a misalignment of the thermal envelope. So here, if I had it drawn out like you were on the slide before, my pencil would have had to come off the page because there's nothing there. This is me standing on the right picture. It's me standing on a service deck looking down into a garage. They moved that demising wall over the garage and pushed it out over the garage. I should not be able to look down into the garage. And then the one on the left is me standing in the living room, and you're seeing daylight over a patio that's shining up over that. In other words, they don't plan on insulating the patio, and I understand why you wouldn't, but the way the home was framed, they don't want to spray over the outside patio because it's the ambient. Why would you spray foam over a porch? But here, the way they framed the home itself and the wall above it, you're going to have to connect the dots. So you have to use that foam and wrap it completely so that if I had a drawing, I didn't lift my pencil off the page because it continues and is always in contiguous and aligned throughout the envelope. So I'm sure, Cody, how does your guys react in the field to see if they saw something that was framed like this? What would you guys do? Talk to the builder and say, hey, we have an issue here that we need to solve? Or would they find a way to foam and fill that?
We would find a way to fill up that area. I mean, it's all about creating the thermal envelope. So, it's I get them to think about where unconditioned space is going into conditioned area. Where can Mother Nature get into the house to prevent the insulation from doing its work? And so in this case here, we would work with them on creating an air barrier in that area so we can fully encapsulate it, so we can make sure if you can see daylight, if Mother Nature can get in, I mean, she's like that unwanted squatter that's sitting outside your house wanting to get in. And so trying to get them to understand that if they see daylight to seal it, and for going from unconditioned to conditioned area, that's kind of what we try to get to simplify it at its most simplest form, because a lot of these contractors, they go in there, they're on piecework, or they want to get the job done as quickly as possible. So if we simplify the thermodynamics of what we're trying to do, it gets them to think about it, simplify it, and then they can go in there and achieve it.
Yep. Yeah, I mean, perfectly way to say it. The one on the right hand side, though, where that duct is that you see going through the service deck, that's basically right almost up against the garage wall below. So that's a pretty big space there that's going to now have to be either OSB and decked for foam, or putting plastic or something there as an air barrier, or some kind of substrate to actually foam it to. And then, of course, making sure, as we always talk about in previous webinars, is that insulation has to be in contact with the conditioned side, which is technically a encapsulated attic, not just sprayed on the sheetrock above the garage, because we're not conditioning the garage. So that,
Correct.
and in
But
Texas,
sometimes,
something like this brings up just absolute massive humidity. Like you said, Mother Nature pushing humidity in the home. This kind of breach of the envelope is huge.
yeah, there's times where, and we've came across this just a recent issue where they had a hard time putting the air handler in the living area, so they'll put the air handler in the garage and then run the ducts going through into the living space, which is fine. You can do that, but now your thermal envelope is not at the roof deck; it's at the garage ceiling, because you have to create a full envelope to make sure hot air, moisture, or anything can't get into that garage. I mean, there's other ways of doing it, but I mean, even if you have an attic separation wall that's separating the garage to the living area, which they did at this point, And they ran the duct right through the attic separation wall, but now your air handler is not truly in conditioned space. So you have to insulate underneath that garage ceiling. So you can create that full envelope. And that's kind of that basic dynamics is where is unconditioned space versus where are you trying to make the conditioned space.
Yeah, and of course, with code now, it's from the 2021 and beyond, basically. But if you have a foam encapsulated attic and you have all the equipment and the ducts in conditioned space, then you have a double the allowable leakage when you test it. But in your scenario that you just talked about, and the equipment is actually outside of the envelope, well, now that changes the target, which means you have to have a tighter duct system. So it brings up a lot more challenges than you think.
Right. Well, the picture on the right looks like that's going to the outside, right? Is that
The
daylight coming out?
Yeah, that's the garage, but that duct itself is a return that's inside the conditioned space.
Correct, but based on what I'm seeing there, the attic separation wall is in the wrong location. That attic separation wall should be on the other side of that garage. Because
Right. They did this because they were trying to save the money from the vertical door, and they incorporated the pull down stairs in the attic as the entrance to that encapsulated attic, which then brought up more challenges because now the pull down stairs was not insulated properly. It wasn't weather stripped. A lot of things had to happen to complete this envelope, so it was a headache for sure.
yeah.
All right, and then we've got a question real quick. I'm going to stop before you get into this because I know there's a lot of information, but this is something that's been brought up by anytime we talk about foam, almost someone brings up this question. And Casey, I appreciate you doing that. He says, what about the risk of shingles when foam is applied to the underside of the roof?
Yes.
I know
So
you've heard it many times.
I have, and there are certain manufacturers that don't warranty, and there's other manufacturers that do. And so if you look at the science behind it, when you're talking about moisture or leakage coming through the roof deck, what is it doing to the shingle? And so, and my thought process and what I've had discussions with different manufacturers is, to me, what would cause a shingle to lift and what would cause it to ruin its warranty. And so we're talking about the underlayment of the roof deck. You're talking about the shingle itself and heat. So if foam is absorbing heat on the surface of the area, you would think that radiant barrier, which reflects the heat, would do
Yep.
more damage to a shingle than foam would.
Correct.
So when you're talking about how moisture can get through the roof deck, that's one of the main reasons why we don't see a lot of closed cell foam out here in on the roof decks, is because if the underlayment and there's water getting through that roof deck, you're not ever going to see that moisture or that water build up until it's too late. With
Hmm.
open cell foam, water will come through it and you will see it at some point. It may take a little bit longer, but I mean, I've just got done repairing three roof decks because water came through the foam the you know because the water the shingle lifted, but the foam is not what's causing that. It's the way it was actually installed. 80% of I mean, 80% of issues underneath a roof deck is really more installer issues than it is product issue.
Yep.
So if the underlayment's not on in there proper and you don't have the proper underlayment and everything, the foam itself is not causing anything for the shingle itself to fail. So there are certain manufacturers, and basically, and if you look in each one of them's verbiage, and I can give you, matter of fact, as we're talking about it, I have a list because I found out from because I was talking with this to places like Builders First Source and So the only two manufacturers that I know that voids their warranty are Tamco and Atlas. The rest of the manufacturers, what they'll do is no different with any other warranty. If you don't install per manufacturer specifications or they see anything that's outside of their guidelines, they will void a warranty. That's no different than any type of insurance claim. They'll find any way to try to make sure that you're not doing it correctly so they don't have to pay. I mean, that's just with any product, any type of warranty, and trying to minimize that risk. But the only two manufacturers of shingles that I know, based upon the distribution people who sell all the products, that it was Tamco and Atlas were the only one that voids their warranty if forms under the roof deck. So the rest of the manufacturers are not having an issue with it. And it really boils down to, when they go to investigate it, that manufacturer, even, when I worked with Owens Corning, I mean, they're one of the largest manufacturers of shingles. It boils down to how well was it installed? Was it a user defect or was it a product defect? And that's kind of what they're going to look at if there's any type of warranty issue when it comes to a roof shingle. Because if you got a tornado coming through or you got hail coming through, that's that's where the claims are coming through, and the foam is not causing or causing any of that issue. If a storm wants to rip out a roof, it doesn't matter what product's underneath it, it's going to do it.
Right.
I get that question all the time, and so
Yeah.
I went and did the research for builders who are doing it, and if they do have certain shingles that they want to install, and if Tamco and Atlas are going to be difficult about it, I'm sure you could still have that conversation with those manufacturers and they'll work with you. But I mean, if two of the 15 or 20 of the manufacturers for shingles have no issue with it, then I don't see it being an issue. And looking at the science behind it, like I said, most roof failures are due to installation issue rather than product issue.
Right. No, great way to put that. Casey, thanks for the question on that part of it. I know Casey looks at a lot of existing houses as well, so it'd be tougher to determine kind of who the manufacturer of the shingles were. And of course, there's a lot of retrofit that's happening out there now as well. Without asking those questions that you went down the rabbit hole to find out, they just take the spray foam, they do it, they're sold that it's going to be better, which it is. Keeps the house more comfortable, but as you said, there could be a possibility of voiding a warranty if that's sprayed under a
Yeah, and
roof
when it
deck with
comes
those
to
shingles.
existing housing, there's a whole lot more issues other
Yep.
than putting the foam under the roof deck that we're going to talk about
We'll
later
talk
and look
about
out
later. Yeah.
for that I think would be more of a concern. But if that roofer is replacing that roof and they know that there's foam underneath there, if you have the right roofer, they're going to know what products they're installing, which would void or unvoid that warranty.
Good. Cool. All right. Well, we think we answered that thoroughly. Casey, if there's any more questions on that, but feel free to put that in the chat. And then Cody, I'll let you take off with your slide here.
Okay. Do I have the ability to go up and down or no? No. Okay.
I mean, I'll move forward. You just say next slide, and
Okay.
I'll take care of it. Yeah.
So, the biggest and a lot of the stuff that I put in here, and we got a lot of feedback when we and when Randy were putting together this presentation. And so I have you'll see a lot of detailed information in here. I'm not going to go into the weeds of all of everything that's in here because I know that the presentation you're going to have access to it. So I wanted to make sure that you had all the references you needed is if you started getting into the weeds or you have a certain question about thermal envelopes, thermal barriers, a lot of the things that I see out here in the market. But if you have that question, then you know where in the code you can reference it, so you have it for yourself. But the biggest problem in a lot of the things that we see is, what is defined as a thermal barrier and what is not a thermal barrier. I mean, there's things out there that are considered thermal barriers, but if it's not installed correctly, it kind of defeats the purpose. I mean, perfect example for me, and I'm sure you guys see a lot of this out here because it's all over Texas, is thermoply. T-ply is technically a thermal barrier, and you see it a lot on knee walls, attic separation walls. Um, and you see it on the outside of an exterior wall. But if you don't put the T-ply on there correctly and you go to foam or even air seal thermoply and you don't have to write nail patterns, you can take that can foam, put it around that perimeter, and all it's going to do is push that thermoply back more and create another hole. I mean, I've seen modern art masterpieces of can foam trying to air seal a cavity because the thermoply is not stapled on there correctly. But it's still considered a barrier. It's still considered an air barrier. Anything that can stop air movement from the unconditioned to the conditioned states and stop air movement is considered an air barrier. Is it the most effective air barrier? Probably not. But there are different products. But when it comes down to certain applications, then when you see certain products, you're going to know there's certain things that go along with that. And the biggest thing for me, and that I've learned the hard way, having these more technical questions is really where it comes down to like attic separation walls. And so, and we're going to dig a little bit into that because, the way we've been seeing attic separation walls separating the unconditioned area, like the garage or a patio and things to that extent, how they're being applied and and how they're being the application to it versus what the actual testing was done for Appendix X testing versus what how we're applying it and what you're seeing on those reports are two different things. And we've been seeing this for a while, and it rose a big, huge question that we've been still working on with different manufacturers, but no one can seem to come back and give me a solid answer on it. But it's something that you guys and people need to know when you're installing foam up against a certain product. Is it is it going to perform the way it says and how it's performed per the testing? But when you're talking about garage doors, sliding back boards, coolers, freezer walls, things like that, you have to have that thermal barrier, especially if it's on a vertical wall. In order for the installation to work correctly, there should be an air barrier touching all six sides. Unless you're going underneath a roof deck or you're putting insulation on a ceiling. So, or if you have a small cavity like a cathedral ceiling or things like that, then the air barrier would be touching all six sides anyways. But allowing air and moisture around the insulation is not a good thing. So when we talk about the thermal barriers and for fire testing, you can go to the next slide. So we're talking about the fire testing for an assembly for a wall. This kind of gives you what they do is, they put the assembly in there, they put a fire in there, and they talk about, how long will it take for that fire to spread based within that assembly. And so, and this testing is very effective. Everybody kind of knows what's going on, and then the theory behind it. And like I said, with every theory or every test, there's flaws behind it. And so the theory is that if you have an encapsulated attic, then there should be no oxygen to be able to feel the fuel that fire, so it would not expand even more because you've encapsulated and there's no air coming in there. The problem that I have with this is that nobody, and it's not even in the codes. How are you testing to find out if there is air leakage coming into the attic? Believe it or not, you can still spray foam a roof deck, and there's still ways airs can get in there if they don't spray in the eaves correctly. And they do that through blower door testing, opening the attic hatch versus not opening the attic hatch. But it's not tested for that assembly. So if I'm testing that attic, there's no test to say if I do this assembly that there's no air coming in there to feel a fire, and it's not even required to test it. They're saying that if you do this based upon the application, and if it's done correctly, then it should suffocate the fire. And then based upon the actual product itself and the material that's going up against the foam, that whole assembly, it shouldn't take It's remain in place for 15 minutes to specify a large scale for fire tests. You can go to the next slide.
Well, before we move on with that, that brings up something that you just connected two dots of a code, two different codes for me, and it just made my head spin. But I always talk about energy efficiency. Foam this, foam that, energy efficiency. But when you're talking about it from a fire spread thing, we do have, and I'll just mention it here. There are people that are on this call that are in cities or locations or counties that do not require blower door testing, but it is predominantly a big foam industry area where they're actually spraying foam instead of using bat or blow. Um, so I mean that to me just adds another complexity to the fact that if it's not being tested, there may be, as we always call it in the field, a foot saw that was used that punched a hole in the envelope that now can feed a fire spread, because the assumption is not there with it's not fully air sealed where it's going to draw air from the outside. So
Yeah, and to give you an idea, and we haven't talked about this, Randy, but just last week we were doing some testing on a house. It was a duplex. One of the duplexes was fully foamed, and the other duplex was not. So we created that separation wall up in the attic. The previous foam installer already foamed the roof deck. So what we did is we did a blower door test, and what we were trying to prove was if we do foam that area, how is there any air still able to get in on an existing roof, never long in a new construction roof? How much can we reduce it if I take the eaves? So what we did is we ripped out the eaves on the outside of the building, and we sprayed from the eave side of the encapsulated attic. So that way the foam gets over the top plate because a lot of the times when you're spraying foam from the inside of a roof deck,
mhm.
you're trying to stop the air, but the exterior wall itself still has air coming in through that wall cavity. So and you can't really get there from the inside of the attic to seal that. So we wanted to see how much air could we reduce by spraying it from the eave side. Now, is it the most cost effective way? Probably not, and that's kind of why we did this study. But we actually were able to lower the CFM of the entire building by almost 500 CFM by sealing it from the eaves after it was already spray foamed underneath the roof deck. So that
Interesting.
tells you that air can still get in there and feed a fire with fire with oxygen in an encapsulated attic if it's not sealed properly. In new construction, you can get to that area, but we talked about existing houses and how these homes are being foamed under the roof deck. Are we really sealing them to the levels that if a fire got caught into that attic, that oxygen from there is not getting in? I mean, and that's kind of why we're doing that testing. But, I mean, but there is no requirement to test just the roof deck to say, hey, I mean, like I said, you open the attic, close the attic, compare living to the condition to the living area, and if there's a CFM difference between that attic versus the living area, then you know that there is some air getting into that attic that could possibly fuel a fire. Now, will it take more than 15 minutes to expose that fire and defeat it? You know, that we don't know.
Right.
But again, with every application and everything that goes in there, there's always risk involved. But yet, I always thought it was interesting that if you're saying that if I use this application and I do this assembly through the Appendix X testing, that it's going to suffocate an attic, but we're not testing to find out if that's the case or not.
Yeah, good point. And of course, my raiders that are on here will back me up on this. There are now houses that are being done that are production builders that are there's no access to the attic from the interior space. It's you can only get there from pull down the garage and then a vertical door. So there's no access from the inside of the home, which doing a a blower door testing, you should have access to that to do a full envelope test, but sometimes you won't. But before we move on, We have a question here if you want to try to address this one.
Yeah.
Mark asks, is closed cell foam the product to use in coastal zone areas for piling homes to keep moisture from being trapped between subfloor and the finished floor, which is going to be LVP?
Oh man, that's a good question
Yeah, I
because
don't know that if you go to the coast or do that very often, but maybe you've been some training that had it.
yeah, because you do see a lot of closed cell foam. Florida went through this. They use a lot of closed cell foam because of the structural purposes more than it is for the thermal envelope. But depending on what type of siding that you're putting in there, and if you don't have, a vapor barrier or there's certain assemblies, I mean, it can cause more harm than good. It, under, in the coastal areas where you have, let's say they have them raised up, right? And you have your garage or your parking lot and they're up on these, 9 foot silks, basically is what I call them,
Mm-hmm.
on top and it's underneath. I mean, the closed cell foam does help. There's other sprayed applied barriers that you can put on the outside to prevent that moisture from coming in that wouldn't be as expensive as putting as closed cell foam. But I mean, and making sure that you have the ability. The biggest part when it comes to doing that is you want to make sure it has the ability to dry. And if it and the hard part with Texas, I always say Texas weather is like playing the lotto. I mean, it'll be 76 degrees one day, it'll drop down to 20, go back up to 76. I mean, it's like looking at lotto numbers. So when you're dealing with that kind of temperature differences, and even in the coast, I mean, I think we saw snow over there in the coastal areas, but yet but they say that's a climate zone one. Do I agree with the climate zone map? That's another beer for another bar, but to say that an area where you can still get extreme heat, extreme moisture, extreme cold in a 12-month time period, to me is not climate zone one. But but again, you're still dealing with different temperatures, and you got to make sure whatever solution that you're putting on that area, you want to make sure that it's got the capability of drying, and it's got to make sure that you're not going to build up that moisture around that envelope because you're not going to see it from the inside. It's going to stay in the outside, and you want to make sure whatever that solution is, that it does have that drying capability.
Yeah, unfortunately, that's where a lot of times the I want to seal everything with for energy efficiency. However, then you turn around and go, but manufacturer makes me leave a weep hole or some way for it to dry or some way for it to drain. Now we have areas of air leakage. So it's sometimes those things butt against each other, but I think durability, resiliency, and health and safety it always will trump over energy efficiency. So, as Cody just said elegantly, it's just how is it attaching it to the substrate? Are you gonna seal it enough to where it's actually sealed? But if moisture gets in there, what's going to happen? So, if it's not sealed properly, I would look at different materials possibly to either connect that closed cell to the underside or just do something different entirely. So, it is done. James put on here there are numerous articles on avoiding moisture sandwich on flooring. So great point, James. Thanks. So you can just Google avoid moisture sandwich in flooring, and that should be able to give you some further information. So
Yeah. And if you want to see an area of the house, and we're seeing a lot more of it out here in Texas, and you want to see how quickly a wall could fail, put stucco on the outside of that building, and you'll see it really fast.
yeah, and as you said, another beer for another bar. That's a whole different topic for another webinar. And we've
Oh,
had one of
yes,
those
it is.
before, but we need to address it again. But stucco is a big issue for water drainage and the durability of houses now. So yeah,
Yeah.
that's a
I
great
always
point.
call it the spandex of building material. It doesn't hide anything.
Yeah, that's a great way to put it. Well, here's your next slide here if you want to move to some special approved alternative assemblies.
Yeah, yeah, where's this is let me make sure I'm on the right one here. Alternative assemblies. I mean, this is kind of the same thing. It just this gives you kind of the detail, but I think we kind of went into it in 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 great detail at the previous slide. It
Yeah.
really depends on the assembly of the house. And I always say, if you know, if you're going to do something, you need to test it to make sure it's going to correct. It's going to do what the assembly says it does. Because you got to realize too. I mean, you're looking at this. You know, they're testing this in a controlled environment. We don't build in a controlled environment.
Right.
So, you know, I mean, so how are you going to know that if I'm, you know, and if you look at that test, what are we doing? They're putting it in a closet and they're doing it in a controlled area, trying to recreate something that's going to be happening in a real life environment. And the only way you're really going to know whether or not that real life assembly is working correctly is by testing it. Is it required? No. I mean, I mean, they don't say that you cannot do this without testing, but because there are jurisdictions where testing is not required just for energy, never long for fire.
Hmm.
Um, and that's kind of where we get into the ignition barriers on the attic separation walls. And we're going to get into that here because there are loopholes and there are areas of concern when it comes to that. And I think we have it in the next slide.
All right. That was my next question to you is when is an ignition barrier required?
So underneath the roof deck, it's not. But when you're talking about going through an attic separation wall or through certain areas, the ignition barriers are required based upon this. And this slide here kind of gives all this slide is just to give you more information on what is considered a no thermal barrier would be required versus where a thermal barrier, not ignition barrier, there's a difference. A thermal barrier would be required. And basically, it's the same rule of thumb we talked about earlier. If it's from unconditioned going into conditioned area, a thermal barrier needs to be applied. And that's kind of what this will tell you. And it does show there, um, you know, in the sill plates and headers, the maximum thickness that would be considered a residential construction is 3.5 inches to be considered an air barrier. So we talked about that earlier, but it says here in the codes. Can you go to the next slide? Because the meat of the bone is where I was. This also kind of gives you an idea whether, and the biggest issue when we're talking about in the attics is whether or not you can use the attic for storage versus non-storage. And that's where the testing comes in the play on in a lot of the areas where, you know, you can tell a homeowner that this is not used. If you're using it for storage in that attic, then you do need to have an ignition barrier. You know, you have to have that underneath the roof deck. But, you know, they put it in their verbiage that an ignition barrier, I mean, this is not meant for storage. And you're done. I mean, you notify them that this is not placed for storage. But we know in real life, you can tell the homeowner that it is not for storage. But they're going to go in there and they're going to put their Christmas stuff in there and they're still going to use it for storage. Especially out here in Texas more than anywhere in the US. I always say, I mean, in most areas of the in the United States, you can barely walk in some of the attics. Here, you can park a car in the attics out here with the volumes and the roof pitches and things like that. So it's hard, you know, but at the end of the day, if anything ever went wrong, and you don't have that the ignition barrier under the roof deck, and that's where we go in there, is they put in there not for storage, so the ignition barrier is not required under the roof deck. Where it gets more convoluted is where we're talking about the attic separation walls, the vertical walls that are separating the outside versus the inside. And I think that kind of explains into the next slide.
Yeah, I think the next one is the one I've put on here. Just
Oh, okay.
kind of
Yeah.
breaking it into inspection of the foam. So what my guys had to do and what I ended up teaching them in the field is, I was in the field doing inspections when foam hit the residential of the high production homes. And then suddenly now we had to decide, how do we inspect this? What does it look like? We are always trained to grade insulation installation. So at the very first onset of it, it was, well, it's foam. It's got to be grade one. I mean, it's always grade one if it's foam, which isn't true because as we see in this picture, there are two stud corners, there are ladder blocking. But if the foam is just, I don't know why they would do this, but if someone wasn't trained fully in installation and they foamed that, and then suddenly you find that just like with bats, there's gaps behind the ladder blocking. That's a separation and a missing envelope of thermal resistance. So suddenly now you're degrading the install. And as you see kind of in the picture above, we see deviations in the depth of insulation. So as Cody's talked about in many slides already, is you have an R value per inch. In our world, if you don't fully fill a 2x4 cavity, then you're not really achieving a 13. Yes, there can be some deviations up to 2%, but if it's really bad, you got to you have to degrade the foam down to a grade two, which now the model needs to be reran to see if it still passes. But kind of go through and explain, how does your guys not miss these areas behind corners, behind ladder blocking, or two stud corners? I mean, I'm sure they do it with a foam gun and it just expands behind it. But how do they assure that even those places are getting fully filled?
It really boils down to education. And just to kind of add to what you were just saying, Randy, is just so you know, the inspection process to be inspecting foam or any type of blown in product that goes into a wall cavity only came into the codes 3 years ago.
Right,
There was no inspection protocol for foam because this perception was is that if the foam is in there, if it it's a grade one automatically. And when you see some of the pictures that Iranian is going in there and showing in here, those deficiencies are no different than if I compressed a fiberglass bat. So, I mean, you're talking about, just like in this area here.
right,
So, I mean, making sure that you pre-walk the wall assembly, especially when you're talking about, like you're saying, California corners and things like that. You just have to pay attention to the wall assembly before you go to spray it to make sure that when you're putting that nozzle, you're not just spraying the surface of the area from the outside, that if there is a cavity that goes around a corner, that you go in there and fill that cavity up before you go in and spray it up. And you bring up the good point when we're talking about nominal fills. I had this, we won't do a nominal fill in a cavity. We just won't. Because the way that foam is being sprayed and the way it expands, it's impossible to get it to go in there and fill a certain area. Nominal means average fill.
right,
So, meaning that some areas in a 2x6, you may get full 6 inches, and some areas you're going to get 3 inches. It's just on all how the foam is cured. So, and then technically in the code, the insulation on the exterior wall should be touching all six sides. So, you're not really doing what the codes are telling you to do if you're doing a nominal fill. I talk builders out of it and tell them it's not feasible because you're going to come in there and inspect my foam, and I'm going to see areas where it's 3.5 inches, some areas where it's 5 inches. I mean, it's just not going to go in there and it's not going to fully fill. It just won't. I mean, I don't care what kind of foam you are, I don't care how good of a sprayer you are. That foam is not going to expand evenly. It's just not going to happen. It's just the characteristics doesn't work. That's
right.
why
And we
fully filling it and then shaving it is the only way you're really going to you're going to get the full R value, or it's going to go in there correctly.
right.
What
And
you're
the
seeing
pictures I have,
here on
right,
these pictures are contractors that are trying to spray the cavity without having to shave it because of the amount of waste that the contractor and going into the landfills are going into those walls. So they're trying to do that without shaving it. And sometimes when you go to shave that foam, you know, it's going to pull apart. So how do you go in there? And I mean, that this is one of the main reasons why I'm not a big fan of spraying foam in a wall,
right,
because of this particular the application, the amount of waste, and then on top of it, you're not maximizing the R value in that cavity. You're air sealing it, but if that's a 2x6, I'm only going to get a 19, maybe a 20 out of that cavity. And I have to shave the amount of waste that's going in there.
Yeah, in these pictures here, I mean, the one on the top left, if this and this is a 2x6 wall, so they can use the nominally filled. However, if it's a 2x4 and it looks like that, that's not correct at all. And the one on the lower picture is a 2x4, which you're seeing shallow filling in the middle, which that nominally filled term, as Cody said, is average. Well, if I have nothing sticking out beyond 3.5 inches, then there's no average here. It's you're deficient and it has a lower R value per inch than required by the model in the wall itself and by code itself.
Right.
But the one on the top left, I mean, if that's a 2x6 wall and that's how they sprayed it, you should, as a third party rater, you would end up doing a pin test like you see in the picture lower. But you pin test it in several locations, kind of trying to figure out, is this nominally filled to at least a 13? Because if they're not trying to achieve a 19 or a 20, they would not fully fill that. If they are trying to achieve a 19 or 20, then that top picture would definitely not pass code because it is not fully filled because that's what would be needed on a 2x6 wall. Anything else to add to that?
Yeah, when we're talking about code, I'm sure everybody on this call can probably agree with me that because it's code doesn't mean that it is fully correct when it comes to
That,
performance.
yes.
We all know
I,
that the software has flaws in it. We all know that all those things occur. It's a living, breathing document that's constantly being moved. The goalpost is constantly being changed every 3 years. We know this. But when you're talking about, trying to do the best performance on a nominal fill, I mean, you're never going to get the full performance of that wall cavity if you don't fully fill it and shave it. It's just the way, those pictures you can see, the picture tells you 1,000 words. You know, I mean, eh, is it acceptable in some cases? Yes. Is it the right way to do it? Because at the end of the day, if a certain percentage of that cavity is not, 6 inches, are you truly getting a 19? But in the software, it tells you it does. No different than on fiberglass. You're putting a R19 in a 2x6 cavity, and an R19 or even an R20 is more than 6 inches. So it's 6.25 inches. So when I put drywall up in it and I compress it, am I really getting an R19?
yeah, nope.
You're not. But in the software, it still says R19.
Yep.
So, and you get the same thing with an R21. I mean, if there's any builders in here, if you're putting an R21 in the cavity and it's being compressed, the difference between on an R20 bat versus an R21 bat, I did the analysis on 200 house subdivision. That R20 was $80,000 cheaper and it
Mm.
filled the cavity versus an R21.
Which
And
you're not
but
getting
you're not
anyways.
getting the R21 anyways, but you're paying for it because it says it in the software.
Right. And that's what the picture you see on the bottom there, we would degrade that to a grade 2. All that really does is lower the R value. But if my model and go down that rabbit hole of manual J says that I have followed manufacturer's instructions of insulation and it's grade 1, well then my manual J and everything else about the energy model proves that it's going to be a compliant. But now I'm out in the field, I'm walking the site, I look at it and go, well, this isn't grade 1, it's grade 2. If the model still passes for energy, that's great, but what you've done now is increase the heat load on the building, which now means the manual J may be incorrect. You may change the house by half a ton, which could lead to comfort issues or humidity or all this other stuff that can happen for short cycling. So, I mean, that's a rabbit hole you can jump down to and just keep spinning around. So,
But you can also fall out of compliance because that house is all electric and
correct.
you're barely passing on the code. You may
Yep.
not be in compliance because it's an all electric. If it's
Yep.
gas, you got more flexibility when it's half gas, half electric too. So there's that issue as well.
Very true. Very true. But this is kind of, I threw these pictures in here. This is kind of what a third party would go in there and do. I don't know if I agree with spray painting on top of the foam. I don't know if that does anything to the foam.
No,
Um,
you're fine.
okay.
Actually,
Well,
for as an installer, it helps me point it out because as you can see, there's a lot of deficiencies in there. And as an installer, I could tell you, if there's installers in here right now. they're probably walking around with can foam filling up those voids because they're not going to bring their machine out there to try to spray it and then shave it.
Correct. And, a lot of times people will look at this, and I've shown people this, in person, and they look at that and go, well, that doesn't look that bad. But if you start counting up everything that doesn't really look that bad, it turns out to be a lot. And so something like this would degrade it from a grade 1 to a grade 2. If the model says we've done grade 1 and now do grade 2 and now the model fails, just as Cody said, you're no longer compliant, which means these things have to be fixed. Same thing with that here, just some additional inspections of that. The one you see on both of these pictures actually are 2 by 4. And both of these, in my opinion, are using the nominally filled term. They're not fully filling the cavity. They're trying to keep the cost down on shaving. You're not achieving the R value that you are A, paying for, and B, what you've modeled that house to be, which then in turn changes other calculations within the envelope itself and the home itself for comfort.
And you
And
can
of course,
go back to that picture, Randy.
yep,
You can see where they shaved and where they didn't.
correct. Yeah, and that pin you see right in the center, that actually has tape on it. The first tape was orange. It was 3.5 inches at the beginning of that tape. So if I'm not hitting 3.5 and I can do that 5 different times in a cavity, I'm not achieving an average of 3.5, which means I'm not actually getting the 13.3 that's roughly a 3.5 inch fully filled foam cavity. And then the other one, there's another black tape that's further out. That was at the start of 5.5 for ceilings when we actually pin test the ceiling as well to make sure that we're hitting at least a nominally. That one you can hit nominally because of the fact that you've got, there's no covering of that from a sheetrock standpoint. And of course, it never goes without saying that people either vandalism or malicious intent or someone had to punch a hole in that to look at something or run a ductwork or run a wire. I mean, a lot of times we say that it's a foot saw. They just punched a hole through it. As you can see, we are pin testing that. And of course, you can see that the foam is hitting that in that one section. Jason put on there clearly a hole for a wire. Yep, that's an awfully big wire, but you're absolutely right. It probably is a 14.3 that they had to cut a hole the size of a basketball so they could clearly know where this wire was going. I'm sure this probably drives you nuts, Cody, on your installation. So you've had to go back out and fix this. I mean, if the pieces have been swept up and thrown away, how would your guys repair this?
Well, in that case, on a hole that big, we would probably have to put some type of netting on the back end of it or something to where the foam would come across, and we would have to full it. You can't fill that with can foam.
Correct.
That's
Correct.
but yet, I mean, this is the end. This is the reason why we went down to 3 air changes an hour because that used to be that we called the Chuck Norris approach of running a pipe through an exterior wall and asking us to come and seal it.
The Chuck Norris approach. That's a good way to put it. And then before I leave this is kind of brings me into another subject. There's someone in the room now that's kind of bringing this up, and I completely forgot. But maybe you can talk about it. So let's say I'm looking through this hole. I see another room on the other side. Okay, I get it. But what if this was the air barrier? It's the exterior wall. I think you guys have a term called bounce or delamination when you have. So the person in the room, Robert's on the call here, and he does this in West Texas. Is he kind of drags his hand on the wall and touches it or taps it? If you hear a hollow sound, that means it's either delaminated or it bounced, and it's not actually adhering to the air barrier. So I know his builders don't like it, but he goes and pulls those areas out to where it actually is adhering to the air barrier, and then makes that actually get repaired. Do you see that from time to time, and what kind of is the cause for that?
Well, I mean, if you're looking at this wall, and the question that first comes to me is where did the foam connect on one side of the wall to where it can actually expand? You have to
Well, I
put
know I
something
see on
on
this
one
one, but
side
what
of
if
the
we're
wall in
instead
order
of
to spray it.
right? So instead of seeing a hole through that, you see OSB. Let's say there's OSB there, and now suddenly it's bounced or delaminated. Is that due to temperature of the foam being incorrect, or the ambient temperature being too cold or too hot? What would
Yeah,
cause something to bounce and delaminate?
yeah, it's all on the mixture, the outside temperature, the temperature of the foam that's going through. the regulators that are in there regulating the temperature of the foam. There's a lot of things that go on when that foam is mixing the A and B side together at over, over 1,000 degree temperature. Is it going to cure? The other thing, also too, is moisture. Water is kind of like kryptonite to foam. So
Mm-hmm.
if you've got a lot of water or moisture buildup in there, that foam will not adhere to the area. So water could also be another issue as well that would cause it not to connect to the area. Not saying that moisture content of the wood itself, but there's a lot of times where you go there and to go to spray on a rainy day, and if there's water in that area, that foam, and you don't know after you've sprayed it that foam may not be in contact to that back area because the water kind of repels it.
So
It
I
won't.
guess you could also see it as, you show up to a call and you're going to spray it, but the night before there was heavy condensation, dew on the grass, and now it's also on all the wood structure. Um, that's something you'd have to look for to not do, so it doesn't, so that way it adheres better if it was drier later.
Correct.
Yeah.
Especially when you're doing this underneath a roof deck and there's leaks in that ceiling in that roof deck before you go to spray it, don't spray
Right.
it.
Right. Okay, well, I'm just trying to keep us up on time here. I know we've had a lot of great conversations and talking about it. We've got probably a little over 10 slides left, so let's kind of roll through this. But now you've got some slides here just talking about ignition barriers. I know we already discussed most of this, so just let me know if we need to just keep going.
Yeah, so and this is kind of like to kind of continue on what we talked about ignition barriers, when it's allowed, when it's needed, when it's not, um, based upon the Appendix X testing. And this is where the issue that I've came across, and this happened with a large builder that we started working with, and we started digging into the weeds of this and found some loopholes. And when you're talking about an ignition barrier, basically what they tell us is that if you use a sugar-based foam because it passed the Appendix X testing, an ignition barrier is not required on an attic separation wall. But if you go into the Appendix X testing on the approved materials of an attic separation wall, and this kind of gives you the definition of it, but if you go to the next slide, and you look at the ESR report on what they say is, and every single ESR report is different because the thicknesses of an attic separation wall, each ESR report will tell you that you have maximum thickness on a vertical wall that you can spray. Now, this particular instance that we came across, they were telling us that we had to spray an R36, and that's a different beer for a different bar, that on the attic separation wall to achieve the R value. But if you look at the ESR report, it will tell you what the maximum thickness that you can spray on the vertical wall in that area. And there are 7 approved materials that you can put on an attic separation wall to get the maximum thickness, or whether or not you need an ignition barrier. Now, the only non-sugar based foam that I have seen that does not require ignition barrier on a vertical wall that I've seen out there is the new natural polymers product that Owens Corning has. So that's why I was using that foam. But go to the next slide. If you look at this on the left-hand side, those are the 6 prescription ignition barriers that you can put on an attic separation wall to require whether or not you need an ignition barrier in that area. Okay? And if you look in there and you look at the picture below, is the most common practice that we see at an attic separation wall. They're usually putting netting on that attic separation wall or T-ply in that area, and then the contractor will go in there and spray the foam on the attic separation wall, which will require an ignition barrier on the backside of that area to, if a fire ever came in within that garage, that it would slow down the foam. But if you go back on all the ESR reports that are in there, None of them, not one manufacturer, has tested netting or T-ply as an approved substance to spray the foam on an attic separation wall.
Hmm.
So that raised the question is well, if that is the case, then the reporting on the ESR report of what it tells you your thicknesses, it tells you whether you need an ignition barrier. That even goes for sugar-based foams because none of those products have tested the netting or the T-ply to say that that is an approved product that you can spray on the foam on an attic separation wall, which technically voids all of the ESR reports on the thicknesses because they never tested it. So I brought this to the spray foam manufacturing. We brought this as high up as we could go to talk about this. So and at the end of the day, they said, well, if it's not used for storage, then we're okay.
Hmm.
And again, you put the sign up there and say, well, it's not used for storage. But if you look at the technical side of the report and you see that those materials on the left-hand side, those are the materials that were used on the ESR report for the testing. And anybody that's been out here looking at construction or on this call, and I can tell you in the last 10 to 15 years, 90% of the application is that picture is what you're seeing below. That is what they are using to create an attic separation wall from the unconditioned to the conditioned area. It's usually this or T-ply. But you can look at every single ESR report and neither one has been tested in there. That's where I have an issue with the industry or what's going on out there when it comes to exposure. Because now I've done extensive research on this, and the chances of that attic separation wall is the reason why that an attic would catch on fire and fail, probably less than 1%. But as a risk management standpoint, if a builder went into compliance or went into litigation and did not install it per the manufacturer's specifications, then it doesn't matter whether or not that attic separation wall failed or not because you did not install it through per the manufacturer's specifications and a lawyer catches on wind to that, you're basically are going to be settling and you have no fight in court because of the litigation. And I've talked to this with several forensic science litigation lawyers who are representing builders throughout the United States, and they all tell me the same exact thing. This is not a code issue per se. This is a risk management issue because of the actual applications in there. So then the question comes down to, and I don't want to get too much into the weeds of this, and we can talk offline if you want, is how, the question that I have is why hasn't the manufacturers tested these two materials on the most common application that is being applied from here all the way down to Florida? Why haven't they not testing? Because the testing for this Appendix X testing is $3,500 for them to test these materials. My, you know, my thesis or my conclusion is that they probably did test it, it didn't pass, and that's why it's not on the ESR report. But this is the most common practice of attic separation walls that I have seen in Texas, and I'm sure anybody that goes in there can tell you that this is the most common practice. And based upon the ESR reports, even the thickness of the wall, where they say the maximum thickness of a wall cavity that can be sprayed on an attic separation wall or a vertical wall, is based upon those seven materials, not netting or T-ply. And T-ply has a fire rating on it, so still don't understand why T-ply is not on that material. But this is something that we're trying to fix in the industry to close this gap to say if something like this does happen, what can we do to fix it and how can we minimize the risk for any builder that is doing this application? So I've been instructing all of my contractors and all my builders, like, you know what? Spend the extra $65 and put some thermoply up in that and just create an act separation wall and minimize any type of risk that will happen. Is it a huge risk? No. It's a very minimal risk. But when it comes to risk, and I've been a part of many litigations throughout the years of being in this industry, it doesn't matter what the risk is. If they find a flaw in your application, you're going to lose that case 95% of the time.
Right.
And so
Agreed.
this needs to, and this is something that you need to be aware of if you're applying this or if you're a builder, that you need to know that there is a loophole when it comes to attic separation walls, and it's a very huge concern. And when it comes to risk management.
Right. And then one thing that's on that list too is I've seen house wrap being used for that. What just talk real quick about is that
No,
shouldn't be allowed either, probably, right?
no, especially I saw a builder that when they were trying to get into the foam business was using plastic house wrap and they went to go spray it. Now, if you're spraying a foam over 1,000 degrees on a piece of plastic, what do you think is going to happen to it?
Yeah. Yeah. Melt.
Yep. So there was a question that we had that someone asked about termite control or termites in foam. I am not a huge expert when it comes to going with termites and using foam. I can tell you that in the research that I have, and that's why I wanted to make sure that you had the resources to go in there. Termites are not, it's not a food source for them. You know, and all the sprays that you're using to do for termite prevent termites from coming into the house, all that stuff would still apply. Nothing really changes when it comes to the inside the cavity of the wall. But I wanted to make sure that whoever was asking these questions or did wanted to know about the practical practices when it comes to foam and termite control in our area, I wanted to make sure that you had this as a reference.
Got it.
And we kind of talked about this already when it costs about cost effective performance when it comes to walls and ceilings. And this is probably the most popular way. Even production builders right now, they may not be net and blowing the walls. They're batting the walls and spray foaming the roof deck in some of the areas. But when you're talking about R value when it comes to a wall cavity, and you can see right here on the left-hand side, spray foam, cellulose, in a 2x4 or a 2x6 cavity you're not maximizing the R value in that cavity. When you're talking about best bang for your dollar when it comes to cost, the net and blown fiberglass in a 2x4 or a 2x6 is the highest performance. Is it the most simplest way of doing it? No, but we all know when it comes to construction, sometimes the best performing house is not the simplest way to do it. But the amount of time it takes to go and air seal a cavity of a wall that's only responsible for, on a high end, 15% of the total leakage coming into the house, air sealing an exterior wall is not that hard. And I have different videos of using polyseal on the exterior wall. There is framing gaskets that you can use to picture frame the outside of the wall at the rim and band joist. I can send you videos on if you would like to see those. We have those. I've created those a long time ago to help with different air sealing solutions to the wall cavity to address that. But again, once you stop air moving into a cavity, at that point, the product, R value is R value. It doesn't matter what type of product you put in the house, in that wall. It's where you're going to maximize the R value. And so far, other than closed cell foam per inch, the blown in fiberglass wall, like you're seeing in this picture, provides the highest R value. And it gives you the best bang for your buck. I mean, in some cases, at an R24 versus an R20, it's almost the same price as if I sprayed that wall. In some cases, it's even cheaper, depending on the amount of surface area. And you're getting an additional R4 for the same price. So, I mean, and then when we talk about the overall performance of the house, and like I said, if you're going to you're going to maximize R value regardless of the foam that you put or what product you put in that wall cavity. You're losing 22% of that R value, even if it's installed perfectly. The next slide, please. And this is why. Because 22% of your house is made of wood, our value of wood on average is about a 1. So if you look at the entire wall assembly, you have a, let's say, a 2x6 wall, R19. Then you got an R1, an R19, an R1. Then you put a window in there that's got an R value of about a 7. And then you look at that whole assembly. Well, you're really not truly getting an R19. On average, you're right about an R15, and that's if it's installed perfectly. But if you put a piece of foam on the outside of the house, and you can see that in the pictures over here on the right, and I slow down that heat transfer, now I'm getting more of the R value and I'm maximizing the amount of performance of slowing down the heat transfer in the house. That's why you're seeing the codes pushing continuous insulation, not just for the thermal barrier, but you're talking about moisture barriers and all these other things that go along with WRBs and the advantages of putting foam board on the outside of the house. This is why the codes are pushing towards it. And a lot of you energy consultants in here, they'll tell you, I mean, if you find anybody that's trying to go backwards in the code, and some would say that the new code, the 2024 code did that, but that's a different bar, different conversation. But this is the reason why they're pushing continuous insulation on the outside of these houses to maximize. Because at this point, when these energy consultants are designing these homes, when it comes to thermal performance, we're kind of squeezing water out of a rock at this point. There's not much more you can do to the thermal envelope unless someone comes up with another product where you can get an R20 in a 2x4 cavity. 2x6 cavities are coming. These are the trends that we're seeing. And this is the reason why continuous insulation. And I always say, if you're going to put foam on a wall, put it on the outside because that's where you get the biggest bang for your buck.
Man, you
And to
break
keep
that thermal bridge. Yeah.
correct. And then this is the other big area that I see when it comes to existing homes. And this is, I can't tell you how many times that I go into a homeowner's house and they want their roof deck sprayed. And I ask them, is it a gas or an electric furnace? They'll tell me it is gas. Is it directly vented to the outside? Or do you on the like on the picture on the right, can you have little vents in there to where you can access the pilot light? And most times than not, they will tell me that the picture on the right is what I see in the attic. And I will tell them that I cannot spray your roof deck if that is the case, because of the fact that if that pilot light ever went out, where is the gas going to go? Now, the most common answers, they said, well, the other contractor didn't say anything about this, and they said that they could spray it. I was like, well, why did they say that they could spray it? And they're saying, well, they said that the gas will, because of the volumes of the attic, that the gas will eventually dissipate. And I was like, well, where is it going to dissipate to?
Hmm.
And the one on the left-hand side is what you call a direct vent, meaning that the gas can't get into the attic. It goes directly vented to the outside. But I can't tell you the amount of contractors that will go in there and spray a roof deck, not only with one of these in here, but I've seen it where they've actually sprayed an attic where they had a water heater in there that was gas. And there's no regulations, there's no anything when it comes to this. If you're talking about doing a foam attic on an existing home and it is not directly vented to the outside and you're a contractor that is doing it, I highly suggest do not do it. This is one of the most frequently asked questions, and a lot of the things that are being misrepresented when it comes to actually foaming a roof deck on an existing home. Homeowners want it. I get it. I understand it. But if the risk that is involved with it, I mean, now if you want to convert that to a direct vent and spend all that kind of money just so you can spray foam your roof deck, that's great. But this is one of the most common areas when I talk about risk. And we talked about the foam underneath the roof deck. That is a small comparison to what I see out here in the market where people want to get their ducts in conditioned space, and I get it, but If you have a system that looks like the picture on the right and it's foamed in there, you're setting yourselves up for a lot of risk. And there was another issue when it comes to this too, Randy, that you touched upon that I thought maybe you wanted to talk about.
Yeah, I mean the one that's also on that slide too. I mean, we're seeing other pictures of uh, vented attics or non-vented attics, then having a metal flue pipe. But is also as adding supplier returns into the attic. So I know you had it on your previous slide there. Maybe you can quickly talk about that. We're already at 12 o'clock, so I know we're running just a little bit over. We only have a few more slides to go. But just, I know that's a question brought up a lot to me is should I allow or should I require a supplier return in an encapsulated attic?
Yeah. So when we're talking about conditioned space, um, in the IRC, it says that in this climate zone, you should actually put around 50 CFM per thousand square foot is what's recommended for supply air. Does not say that you have to put a return air into the attic. Because once you start putting return in there, I mean, you might as well just drywall the roof deck and add the living space to it because it's an actual fully conditioned space area. But the reason why but supply air in a hot, humid environment in an attic, if you're trying to dehumidify that space, then that's why they recommend that you put 50 CFM per thousand square feet in a conditioned attic. You do not need to put a return in that area unless you plan on living up there.
Mhm.
But and the other issues that go along with it. But I mean, we're talking about stack effect, hot air rising coming into the attic and so forth. But for dehumidification purposes, because we do get pretty hot, humid attics, and for that purpose, that's the reason why they recommend putting some air in there for dehumidification purposes.
Yeah, and
Will it
then
rot the roof deck if you don't? No. Where the roof deck gets rotted is from the outside of that roof deck is where you're going to find more of an issue than on the inside of it.
correct. And then of course we also I like to put in here other things to consider is if you've got ducts in conditioned space and you're an inspector and you're looking at that is making sure those ducts do not come in contact with each other. Because as Cody just said, we have stack effect, we have warm air. Warm air carries moisture. As it builds up more in the attic, then you get condensation points. So these ducts should be separated even a half, a quarter of an inch, just separation instead of having those things in direct contact with each other to keep that from happening. We just kind of discussed this part of it. I wouldn't put a return in there, but that kind of goes into the our understanding of well, if I need to dehumidify, then I need to pull the air out and run it through the system to dehumidify. But really, the supply, all it's doing is changing the temperature of the air, changing that condensation point to where you're lessening the chances of that actually happening. And then a lot of people, you still have the bid depending on the size of the home and the big the attic. I know Cody mentioned it earlier about we can park cars in there in Texas, and that's true. There's a lot of places for moisture to go, but the more it continues to build up in these hot, humid summers that we're getting from day on end, it can condensate even more. So I put this on here. I know we've just got maybe one more slide, and then we've got our contact information. But do you want to just talk about this on your what
Yeah,
you've got on the
this is
slide?
just what it talks about safety. I mean, in this industry, I mean, we see it left and right. I mean, a lot of people see the money when it comes to doing spray foam. They get it, but not everybody is doing it correctly. And that kind of hurts the industry altogether. You get what we call the buck in the trucks that are going out in there. And this is just kind of like if you're going to hire a contractor, just, you know, do your research. I always recommend, look, I'm never going to be the cheapest. If you're going to find somebody else that can do the work cheaper, that's fine. But I always say if they haven't been in business for at least, a certain amount of time, because if anything happens later on down the road and they're out of business, yeah, you're kind of screwed. But I mean, you want to make sure you got somebody that's been doing this for a while, has been certified, understands the science behind it. The biggest argument that we had when I was first at Owens Corning is, I mean, we have foam all over the place. That foam board that we use on XPS and things like that, That's all been manufactured in a controlled environment. It sits in a warehouse for 30 days to off gas before it even being sold to the consumer. And now you're asking a contractor to do it in an uncontrolled environment and to hope that the off gassing does not happen after doing it in an uncontrolled environment. And if you have a contractor that really doesn't understand the science behind it, I mean, someone that goes and buys a truck has now become a professional chemist. So you want to make sure that you have the contractor that really fully understands and is going to be there and back their work over the long term. And all this is just to give you some ideas and the right questions to ask if you're hiring the right contractor.
Yeah, and I think the sad part is when you have retrofits, a lot of times they don't pull permits to do that. So cities can't have a checklist on there to say, are they following all these standards and safety measures as well? So
Well, there's no permitting and no licensing for a contractor in new construction either. So,
true. Well, at least you've got somebody walking it and putting eyes on it. So I know
correct.
we ran over just a little bit. Cody, thank you so much. I know I tried to address foam in the past on a webinar. You got way more technical information than I do. This is Cody's information here. Feel free to reach out to him if you have questions. He'd be able to, he's just always welcome to take some. He's got some good information. If he doesn't, he will definitely look up the technical information on that and get back with you for that. So, as always, connect with us on eepartnership.org. We're also on Blue Sky as well as LinkedIn and on X at EE Partnership. This is our direct number to our office. My contact information is here. Feel free to share this with anybody if they want some test prep or if they just have questions about energy code or ASHRAE 90.1. As you can see, Cody is just one of multitude of people that we have in Spear that we can talk to as technical advisors to help assist us with things and questions that we may not be fully versed in. So thanks everyone for sticking around. Sorry we ran a little bit late, but I appreciate you guys being here. And if you ever have any questions, feel free to reach out to us and we
Hey,
will help in
Randy,
any way that we can. Yes, sir.
I wanted to ask one or point out one thing, and I hope that a lot of the building inspectors are still on because we never got to it.
Go ahead.
Recently, we've been seeing a lot of, I've been getting failures from the building inspectors on if we're foaming a wall and we're foaming the roof deck. I've been getting failures from the building departments saying that I am not poly sealing the walls. They want an actual stage one poly seal on an exterior wall on a foam house. And it kind of defeats the purpose. I've been getting text messages as I'm doing this procedure right now from a building inspector who failed my builder because I did not poly seal the exterior penetrations on an exterior wall that is going to be foamed.
Mm-hmm.
And I just want to point out that on the interior wall top plate penetrations, we do it all the time. We have to air seal the top plate penetrations on interior walls. On exterior walls, the foam is doing the job of the poly seal. So I just want to make sure that they understand that when they're going out to inspect it, if it is a full encapsulated wall and they are spray foaming that wall, that a poly seal on an exterior wall is not needed.
Yeah, there's a lot of people in the chat that's agreeing with you, but I know there's some out there that are not fully versed in that and they need to understand it. So, foam is the air sealer that you're looking for. Additional polyseal is not required. So, I
Yeah.
fully agree with you.